Welcome back to We Do Science Podcast, a podcast by biomedical engineers. I'm your host Giridhar.
Hello everyone, my name is Ashita Kamal. I am just audience here for further discussion.
Hello everyone, Cherry this side, and I will be leading with a topic today that is time series data in biomedical.
Before going into the topic, you want to discuss anything like how we tried making this podcast, and we took one small like a big gap itself. We tried to analyze what things are required and we tried to solve few problems. In that solution, like we didn't find exactly what might be the exact output, but we tried to update few things. So this podcast might give few versions of it. It might not be consistent, but we tried for new plans.
I guess it's been a long time we haven't recorded anything, right? And we moved from the offline recordings to online. It was a bit hectic at that time, but yeah, the qualities and things were consistent. But after a gap, we are trying new things as we are doing this podcast online from our home. So there are some things which we are working on and we will be improving.
It's like it's been so long. We are not recording any video like podcast or anything.
Yeah, we were busy with people, right? We were having guests, we were having everything, but that thing was the timing, right? That everybody needs to be there at the podcast. So that was the problem for a few days. But yeah, fine.
Timing
We are starting
also
again.
in between that we having exams and so many things happens
Yeah.
in between now. So we don't get much time to record videos. So yeah, we will continue after this. This is just a starting.
Okay, and today topic will be hosting by Drona itself, and he have few concepts, interesting concepts today. So can you explain any brief on it? What we are
Okay.
going through?
So, yep. So you guys are from BME, right? And I am from IT. So there is a link between both of them, and that link I'm going to talk today. Okay. So you guys work with machines. You guys work how the things are. You guys build it, right? But there are few things which we add on. Those are the machine learning integrations or deep learning integrations which we are talking about, right? So you just tell us that these are the cases, right? And we are upon it. We are building it, right? So the thing is, there are some things which I don't know. Right? I just know those things are input. Just like I don't know what is that ECG signaling and all, right? What is EMG, PPG? I don't know, but I just know those are the signals, and I can train my models on it, and I can find some few insights and all those things on it. So I was going through all these things, and some really interesting thing I found is these days, earlier what it was that people used to have just alert system that a single alert system that it calculates all the values. It sees that okay, his blood pressure is above 180, right? Now this is a critical case. We have to turn on the alert system and all. But these days, what happens is we are monitoring the complete health, okay, of a person which is in ICU bed or any testing bed, okay. We are monitoring them for hours. We are trying to find all the patterns that how their heartbeat goes, how their SO2 levels fluctuate, okay. And accordingly, we find some patterns. Earlier, it was manual work from our doctors or our BME engineers. They try to find all those things, right? But these days, we are automating it, and today I'm going to talk about those automations only. You have any questions or something?
Yeah, and like, why are you only interested in that kind of area, like to work with?
Okay, so yeah, as I said, it is the bridge between biomedical and IT, right? That's the main thing I took this topic for today.
And one thing like I felt a little cautious about it. Every
Okay.
uh, department itself is correlated for the application purpose. Is
Yeah,
it
for the
correct?
application purpose.
Yeah.
Yeah, okay. There is a one like I can phrase it like this that there is math. Okay, math is a tool. Similarly, CSIT, these things are just a tool for improving the efficiency of other departments. Okay, earlier there was things that people or HR, they have to go through manual shortlisting of all the applications. Now what we do, we have a link, we fill the form, automatic shortlisting is there. We get the best out of best candidates and we interview them. Out of thousands of candidates, we just have to interview 10 best candidates, right? All the things are automated. CS on itself doesn't have a problem to solve. We jump onto other domains, we seek their problems, okay, we see what problems they are facing and we solve it.
Yeah, that's nice idea. Like if you work properly in that field, then it will be a very nice thing and nice outcome we'll get. Because as a biomedical professionalist, we know coding, we know like different developer things also, but not in that sense as CS or IT guy person do. So that's
It's just like a person, you know. We know law. We know a law a bit that what are our rights, what are the things which we can do, which we cannot. But we don't know law in like a judge will know, right? The level of law we don't know. So it's similar to that. Before that, let me explain brief about what will be the main things we will be discussing and how the things will work. Okay. So the thing is that first I will be completing this topic and then I will tell you more things about how what are the loopholes in AI. Okay, people these days are fearing that AI and all those things. So I will be telling the loopholes which they should focus on, which they can fix and they can prove themselves as a human that why the human is always needed in a system. Yeah. So the thing is that I started with the topic, the diagnostic thing, right? So just suppose that we are having a patient in ICU, right? Earlier, the system, how it works, I told that there was an alert system which only triggers when the limits hit, right? When the limits of ECG or heartbeat or blood pressure hits, then only the alert system works. But the problem here was that just in case a patient is in critical condition and we are going to know it just 1 second, 1 minute ago, right? We won't be knowing it earlier from hours or from days. We won't be judging it. The only thing we can see is, okay, now he's in problem, now we have to call everything and arrange everything. That becomes hectic because the duration you get for fixing all the things, arranging all the things is very less. Like maybe 30 minutes, maybe 1 hour, not more than that. Because the patient we know that patient is critical, then we get the alert system, okay? But what today's machines use, okay, majority of the hospitals I have seen has implemented it already, that is an ML based system. What it does is regulates or it takes the sample, okay, every second per hour and then finds the patterns out of it. So if he sees that there is a problematic pattern and this person can get a serious health condition in next few hours, okay, it already alerts everybody. So what are we having here is we are having a time span of like maybe 5 or 6 hours before the patient is going to be critical, right? Here there is one thing that is false positive and true positive. If somebody is from ML domain, he will know that even if we are having a false positive, just like even if the system says us that okay, he can have a heart attack in next 4 or 10 hours, right? And even if it is wrong, it is totally fine. We are not losing everything, right? We are not losing anything. We don't have any problem. But if there is a true positive, right? If our model can predict hours before, 4-5 hours before that we are going to have a heart attack. So we can arrange everything and we can save that life. So those things are the advantage here. We get better efficiency, we get more time, okay? We are predicting the things earlier. We are not having an alert system which is going to trigger only 1 minute, 2 minutes ago and we have to rush everything, okay? We can plan everything beforehand. So these are the advantages we get using an ML system over a traditional alert system. There are few components which I would like to say. There are noises also. Just in case, if there is patient, okay, and if somebody is, if he can see everything, fine. And if somebody is want to threat him or giving him if somebody comes in the hospital bed with a knife, obviously the patient will be getting some heart attack or something, like not heart attack, but heartbeat, his heartbeat will increase, all those things he will be, panicking and all those things. So here, what our model will say that he is going to be in a critical condition, right? Something like that. A better example can be if a patient is there, if he get overwhelmed out of something, right? If their parents come or something, or maybe their partner or something, so they get overwhelmed sometime also. and those time also they get the similar signals. So then we can get all those false positives also. We call it as noises. So we out of all those noises also we can also get the alert system or whatever the if we are having a system that gets activated. But we don't want it to get activated, right? So we are working on building more efficient systems which can reduce noise to minimum and increase the probability of having only the right, only the correct cases which we are having. So here we are.
I have one question actually, like how that prediction thing works in ML model. Like, do you guys like taking the data out, the previous data of that particular patient, or like you guys are overall like analyzing the data which is present?
So that's a really good question. So what, how ML model works is, we are having data of like 1,000 patients, okay? And out of 1,000 patients, we can find some patterns. And now we will be thinking, like linking those patterns that, okay, if we find this pattern, and was that patient got the like critical condition or not? Yes or no? Right? If you got the critical condition, that means this pattern. If you find this pattern, that means this is a risky pattern. So we classify all those risky patterns in a table or in a like we use by the way we use different in time series data. Their formats are different. Okay, but in simple ways we can say that we classify all those in a table. That okay, this pattern is risky, this pattern is normal, this pattern is moderate. Okay, and on basis of that we judge. So yes, you are right. We analyze people. Okay, we analyze patients, and from those previous data we are going to come up with the model which is going to predict the new patient which we are having.
So like I have one other question in it only. Like, see, you guys are taking overall data of different patients, or you guys are customizing it for a particular patient because each patient have their own thing, na?
Okay, that is a really good question. So the thing is, if we are overall generalizing it now, that can be a problem. So we have to make both the models, a general model, which is a general for a general purpose model, which is called a baseline model, which is a overall data. Then there are specific data for male, for female, for children. Just we as we know that women generally have a low, not low, a hemoglobin problem due to their physical structure, right? So if we are linking that with a man, that can be a critical case that, oh, he is having low hemoglobin, something like that. But it's not the case with females. So we have to also consider that which type of patient we are treating, but we also need to have a general baseline model. So how it is that we are having custom models also, and we are having baseline models also. So both models predict, and after those predictions, we try to find the best prediction which was there from our previous information which we are having, and we treat accordingly.
And I have one doubt.
Yes.
So, every computational process takes time, right?
Yeah, you do.
So, if we like exactly calibrate the predicted results, like what
Okay.
can be the like fastest time we can achieve?
Okay. So the thing is, as if you are going, you are saying about the time, right? If you are going to calculate the time for whole series, right? It will obviously take, like we are going to compute all those things. It will take time. So what it happens is we are having two layers. There are different layers which are working there. So the first layer which is working is the base layer which we are talking about. That is a traditional system, right? So it will always be there because if we don't want our model to go through the heavy computation and come with a conclusion when we can already get a conclusion from 0.00 milliseconds, which is a traditional system which is working. For an example, if somebody is having a blood pressure more than, I don't know what is the unit of blood pressure. So let's suppose in hertz, because we calculate data in hertz. So if a patient is going to get a critical condition, 50 hertz is a critical condition. If it is going to be 70 hertz, right, it is a critical condition, so we want there only the system should alert. We are not going to compute for an hour, then calculate the pattern, and then going to come up with a conclusion that okay, this patient is critical. So there are different things. We are having a traditional layer also, then we are having a pattern layer. So even if pattern layer is taking time, we are already having an alert system which is working for us. So it is just like an orchestration that everything is there.
And any possibility of getting like directly the hardware advantage in this ML, like
Generally, for these cases, as we have already trained the model, training purpose do take time. But when we have trained it, we got all those patterns. We categorize all those patterns, right? So we don't have to like compute too much things. We just have to like sample, and there is semantic indexing and all those things. We just have to calculate it, which is really fast because hardware these days are really fast. Okay, there are three types of processing systems also. If you know, there is TPU these days, which is tensor processing
yeah,
unit.
yeah.
So we can use those also. There are GPUs, there are CPUs. CPU is generally faster, and I guess a normal CPU, which we are using in your phone, or not in your phone, but in your laptop and all, those CPUs can also process those calculations really fast. Those calculations are not much tough because we have already trained our model, right? So we get all those filtered data. We don't have to train all those model on that time. We are just going. It's just like for an example, I will give you. If you are having a child, okay, if you are having a children, you train him really efficient on writing or any skill, right, or predicting that how the chart will go or a stock price prediction. You train him really good. So the training can take 15 years, 10 years, okay. But after he is trained and he is he's good with his work. Now he can just see the chart and predict that okay, what will be the output, right? So it will just take him 5 minutes, or not even 5 minutes, 5 seconds just to analyze it, because he have already trained himself for 15 years. So similarly, our model training do take time, but prediction part doesn't take time. Okay, so this is the
So simply like can we say like this patterns it have to analyze frequently
yeah.
that will be making faster for predictions, right? Okay.
Yeah, for predictions it's really fast. Okay, for predictions it's really fast, but for training it's slow. For training we have to give lot more time, but for predictions and for when it is in deployment phase, it's really fast. You just have to predict.
And what are the like risk managements in it if anything happens?
Yeah. So as I said that there are false positives. So false positives are generally not that risky. Even if there is alert system, somebody can come and check okay whether the patient is good or not, and we can do it manually also. But there are more things that as I said, there are different layers which are working. So first layer was the traditional layer.
Yeah.
Then the layer was the prediction layer. Then there was the pattern layer. After all those layers, then we get a conclusion that okay, that what do we need to activate the alert system or not. So it's like there are different layers, there are different security layers which are working. It's not that problematic. It depends upon how the architecture is.
And
In general,
Got it.
yeah.
as you said, currently the systems are maintaining only the threshold values for
Yes.
the alarm systems, not much efficient. Even I saw a few like sudden triggers might not be most accurate one, but
Yeah.
those are not properly used for the application purpose, I feel, in current systems.
Yeah, but we are working with the systems these days now. But if you go to hospitals and all, they are already using all these systems,
Yes.
which are working with multi-layer orchestrations. Okay, so they are really efficient with it. They are investing all those funds on these layers because if see, the best thing is the more time you get, okay, the better chances the patient is to survive. If I know that okay, this patient is going to be getting a critical condition in next 4 hours, I can prepare everything beforehand, right? But if we were using traditional system, we will just get this alert 1 minute or 5 minutes ago. So that is a problem. But yeah, we are having all those systems currently working for us. So, and we will be improving it soon.
Sure.
Got
Yeah.
it.
Okay.
So let me just tell you the inputs which we are taking, okay, for the system and how the system works. So I don't know much about this, but I only know these are the inputs for my system. So there is something called ECG. Can you explain me like what it is used for? Just tell me a brief, okay? So this is one of the inputs which we are taking from the patient.
Yeah, okay. Who you explain or we?
Explain.
Okay, if you don't want, like,
Okay, yeah, we
I
No,
guess,
can
no, no, yeah.
go. So
No,
I guess
we.
it is,
ECG,
yeah.
ECG is the like prayer parameter that we can get from a patient, and it's have like very important values within it. So take it like it's the exact values of how the conductivity of heart and how the
Okay,
electrical
related to
properties,
heart.
only the heart. Since
Only
heart
the
is,
heart.
yeah, since heart is one of the important organ that we are surviving, so it predicts like it shows the graph of how the electrical activity of heart functioning.
Basically, electrical conduction of heart, the heart beating,
Okay.
relaxation, contraction of it.
Then,
As you said, we
And
can
and then one graph will generate, that is PQRST graph, and then
yeah.
QRS is a
So
complex from which we get the result.
the graph is generated from the signals, and we do operate on those same signals only.
Yeah.
Yeah. Then there was something like EEG, which was the second parameter which we were having.
It is for the brain functioning. Brain basically it helps to analyze the signals from brain, and there are like different types of signals from which we can use it for our analysis. That is alpha, beta, gamma, theta, and
Okay.
each having different hertz of frequencies. So
and
yeah.
Yeah.
one thing I just wanted to like mention,
Hmm.
you heard that Neuralink also, right?
Yeah, I do.
So these are
Yeah.
the like you know it better, I think, Drona. But I
Yeah.
got to know
Yeah.
that they are working on this EEG recordings as their prayer acquisition data, and they are playing with it to get operated externally, like without using our hands, just with our brain waves, they can operate systems. I got to know
Yeah.
that. Yeah,
There was one more thing, which is a brain computer interface, which is
yeah,
Interface.
brain
Yes.
BCI,
computer.
right? Which
Yes.
takes signals. And there was one more. I don't know it was fake or not because I never heard of it. There was a YouTube video I saw, and they were having some chip on their heads, okay, and they were able to think like make a what I can say, that they were able to make a video of what the person is thinking, or they were able to screen it out, right? But I don't know it was
Yeah.
real or fake because I never heard of it, because it was such a great technology, right? It should
Yeah.
be it was like 1 years ago I heard of it, but after that I never heard of it. Do you
I
know
don't
about
know.
it?
No, I have not seen it.
I guess Giri do. You do, right?
No,
You didn't.
I just heard
No.
that we can like able to give the control access, not exactly the visualization. That one I didn't heard.
Visualization is not there, I think.
Yeah.
I will. I'm not aware of it, but I saw the video. Maybe it was fake one or whatever. But it was just like it was a starting phase of all the signaling and right when I was getting into time series data, and it was really interesting that you can get all those signals, predict, not predict, also you can understand that what the signal wants to say, and you can just screen it out that whatever the person is thinking and all these things. But when they were trying to send the signals to somebody's brain, the brain doesn't understand the signal and rejects it.
Okay.
That's
Got it.
really good stuff, I feel.
Yeah, if it is if somebody can build it, it's a really good thing. We can understand what the person is thinking, and if he's lying, if he's not lying, if he cannot like there are a lot more things we can understand, right?
Yeah.
So it was a thing. It is really. Then there was three more parameters which we were working on.
Yes.
One was respiration, which is like how the person is breathing, how is the rate of breathing, right? And
Yeah.
then there was blood pressure. I don't know how do we get this blood pressure. Is there a machine or something for a constant signaling?
Can we do one thing? Like
What?
you said all the like, can you list out all the parameters? Then
Oh,
uh,
okay, okay.
let
I will be
we
listing out all the parameters.
guess the like me and Harshita guess the like whatever the parameters exact name
Okay,
and
okay.
how it, yeah, that,
So you just explain it also, right? Because in the data I was stating, it was just written EMG. It was not written the complete name of it.
yeah.
So
Okay.
starting from ECG, just tell me what is the complete name of it and then what it is used for.
Harshita, we'll go one after one.
Okay, I'll start. ECG is an electrocardiogram, so it like records electrical activity of the heart, basically the electrical conduction,
Okay.
and it having different graphs while recording. That is PQRST graph, and this is a very complex graph to understand, and it also having different hertz of frequency by which we can to know like how our heart is working.
And a small suggestion, can we go directly like we said EEG and EEAMG
Okay,
also,
so
right?
we'll be,
So we'll
yeah.
directly
So
move whatever we didn't discuss.
okay. So we will be jumping directly to EMG
Yeah, okay.
because
EMG,
we
it's
discussed
like,
ECG and EEG.
okay, then there is EMG, that is
Yeah.
electromyogram. Electromyogram, that is like it records electrical activities of skeletal muscles basically. So it is just like the pressure which you are giving to your muscles, okay, and what kind of frequency they are generating. It could be like by bending your hand and doing any physical activities. There are like different types of devices which are available which conduct EMG continuously for 24 hours for
Okay.
the people having some muscle
Can
issues.
I watched a movie, okay? It was
Oh.
there was a person, he was in coma or something, and
Yeah.
then he just moved his finger, and then there was some graph which was going up.
Yeah,
It was due to EMG, right?
yeah, could be, you can say exactly not,
because his
but
muscle
yeah.
moved and all.
See,
It's
fingers is something, it's very small signal, okay? The
Okay.
basic EMG signal we're getting from the big muscles, like from our bicep, triceps.
Okay, okay.
to
So if
specify,
somebody, yeah, if
to
somebody is coma, right, and if
Yeah.
we are having a EMG signal installed with the like his bed or his body, right, so we can understand that if he moves or not, right,
See,
if
there
he
are
did
two
move or
types of
not,
EMG.
because we can,
Uh,
yeah.
See, there are two types of EMG. Okay, so it depends what kind of EMG you guys are doing. One is like something which can be little painful, but it detects almost every movement of the muscle. But what we are doing, that we are using like electrodes, non-invasive basically. So that is not much harmful. We're just taking records and it will be easier. And there are like further cases and further different machines. So it depends.
Okay, for you, Giri, there is PPG. It was a signal which you are using.
what is that?
PPG.
PPG.
PPG, I didn't heard.
You
What's
didn't have PPG.
what is that,
PPG
Harshita?
is something
It's
like it's an optical sensor which used to detect like blood, peripheral blood vessels का जो volumetric changes
if
होते हैं.
yeah, if you know, there is a PPG installed in your smartwatches also.
Yeah,
Okay.
yeah.
That senses there is one signaling na, that SpO2.
SpO2,
Yeah,
oxygen
all
Okay.
those
level,
signals. It's used to,
oxygen
I just know
saturation
that
level.
because it was written there, the SpO2 value in the blood, right? So it was there. I don't
That
know
should be
how it works and all.
99%.
Okay, that's a good thing. Apart from that, we already talked about blood pressure, but you didn't told me that how do you get a blood pressure data per second? Because I already like only saw that machine which was pumping machine which was
Yeah.
used earlier. So which machine we do use for getting blood pressure per second?
Per second.
It's like for blood pressure, basically, it's the it's not exactly mentioned with the period, since it pressure dependent. Like if you're like, let's say an example, you take your arm like here, shoulder muscles, you are squeezing the vessel like veins to stop the blood flow. So here the main accusation part is that you are stopping the blood vessels to find out its pressure values.
Okay.
Fine,
But
if
it will
you
be a discrete value, right? I was thinking about
See,
how
you
do we
can
get
take
a continuous
standard
value.
deviation. See, you take 5 to 10 result continuously, and then you can take standard deviation of it. So you'll come to know the average value about that blood pressure.
Okay, so we can
That
deal
will
with
be
it.
yeah. It's like a little statistical work, but there are
Okay.
many like different types of equipments for this also available, manual and then electrical and like different. So it depends what type of equipment you are using.
Okay, okay. So, ending with that, this was the 5 6 signals we were working on. There are
Okay.
much more signals, which was like for eyes. There was some signals, I don't know much. There was some signals for glucose level or sugar level in the body and all. So those were the things. Apart from that, when we are making those models, right, we are working with like different analysis. So there is time domain analysis, okay. Then there is frequency domain analysis. Then there is wavelet analysis, and then the ML part which we are going to integrate. So these are the things earlier, as I said, who people are working on these patterns and all. They were working on this only: the time domain analysis, frequency domain analysis, and wavelet analysis. Now what we did is we just have automated it. It's like it's not always effective. We always need a person to moderate it. But out of like 100 cases if we are having, we will get a better result in 88, 91 cases. We will be having a good result. Generally, depending upon which category we are having, if it is a child, okay, we are not having much data, so we cannot train our model on those data. If it is an adult, we are having better data, so we can train our model are much more trained on that. So the thing is that this frequency domain, here we are using frequencies from low frequency, high frequency. We are calculating all those things. There was a chapter in first year, first semester, which was Fourier transformation. If you have heard
Yeah.
of it,
Yeah.
it was really boring at that time.
We still learning that only.
Oh, you're still learning that. In my batch, it was Fourier transformation, and it was really boring. Just we have to just convert things and all.
Yeah.
But the implementation of it was really like whenever I see something good, there is always a Fourier transformation involved in all those computations. So the thing is that these things are important if you're in first year or second year. If you're getting all those mathematical subjects, do go through it, because these are the subjects which are going to
Very
help
important.
you. Yeah, very important subjects.
Like even in biomedical,
Yeah.
this basic Fourier transformation still works. Like we have signal and system, and then again we have signal processing, and this time we have image analyzing, image processing, and each and every subject having Fourier transform in it.
Yeah, that is really important for you. So apart from that, there was in wavelet analysis, there was one more mathematical thing which we were talking about as discrete wavelet transformation.
Yeah.
So these are the only computations we need to do. Sometimes it get really complex, so we also need to have filters on that. But these are the things we compute, and after that we train our models, right? So that's why it takes really big amount of time to train models. The prediction part is short; it's not that long. But the training part is, it takes days, it takes months for training those models.
Yeah.
Apart from that, these were all about this. I was thinking about talking a brief about the security issues which we face. Okay, so if there is something before that, let me tell you that if we are not having all the signals also, right? But if we still need to calculate the values. So that's why we are having those systems. We need to train different models on different systems, just in case we are not getting the ECG value, right? But we are having all the other values. So still we need our model to work, right? We don't want our machine or our alert system to break on that. So what we do is we find the different values of it, okay? Just in case we are first having out of all the input parameters, we are just training our models on 2 parameters, then other 3 parameters, then mixing it, trying other parameters which are important, which can be missed, which cannot be missed, and we are making different models, right, on different parameters, so that our model doesn't break when it is in the operating a person, right? So this was the thing for the security issues which I was talking about.
But we can't miss any value apart from which we discuss, because all the parameters are important in it, I feel, because ECG is important, EG is important, EMG is important, because all these 4 5 parameters are basic necessary thing to understand what kind of treatment is required for a person.
Yeah, I guess to get a best result out of it, yeah, those things are really important. But the thing is, if, for example, we are not having a respiratory data for now, right? So we cannot miss all those 4 data. We have to still operate. and our
See,
machine has.
but
Yes.
what if like they miss the ECG part as you said, and that person is having only heart issue?
That will be
Then
serious. So that's why I said that's why I said that there is always a human intervention which is required for operating to know that whether the system will be working whatever it's told, right? But we want to know that whether what the system is it doing it for right or wrong. So that's why we need humans for that. And if he is having a heart problem, obviously those signals will be
obviously
important.
he will die,
Yeah.
na? Of
He will
course.
die, obviously, because his heart is in the critical condition, not other parts. So other parts will be working fine. Our system will be thinking that okay, the guy is really fine, doing well,
Yeah,
and
that's
suddenly
what.
he
And
is
still
dead.
we need like human
Yeah,
interface there in it, na? So yeah, that's what. Okay.
So these are the fallback systems or fallback responses we need to make. But I guess on the production level, they do think about all these things, and they are having some systems to tackle it. We were talking about the AI security issues, right? You want to start with that?
Sure.
The thing is, as we know that there was a problem which we were facing earlier, which was like people can generate any kind of photos, any kind of videos, right? Just giving them a prompt, okay? And our AI models doesn't know that whether to process that prompt or not. So there was not a security layer which was there. For example, if I can, you just said me before this meet that there was a security threat which is like if anybody can give a prompt that generate me a check value with a sign with this value, and it will generate an exact photo of it, right?
Yes.
And that is really problematic thing
That
because
happens. Few days back, I've heard like some guy that
yes,
they given a prompt to AI to make a check, okay, and it created it, and there was a fraud of 68 lakhs.
see, so those things are real, and there is still not a security layer which should be there
Yeah.
in the LLMs which we are using. There is one more problem as a developer which we are having is all those data, if you are using Copilot, if you are using any of the assistant, right? They go through all our data. Fine, totally fine.
Yeah.
But the thing is, there is a button, if you know, in all those models, if you are using, there is a button that use your data to improve the model. There is a toggle.
Yeah.
And it
Before
takes all
before
your
starting
data.
it, they'll ask
Yeah.
you. Yeah.
It will take all your data and send it to the server. Now the thing is, your API keys also get sent to the server, and those they use it for training models and all. Now the thing is, if somebody asks you, okay, I don't know whether they have installed the security layer now or not, but before there was a problem that if you ask LLM that can you please give me the API token of this website, okay, and as they are already having data, they are not having any security layer, so they also give sometimes those API layers and the endpoints, right? The tokens which are a sensitive data, which are like a key.
Yeah.
So if you don't know, let me explain it in a very normal term or very easy term that if you are having your house, right? If you buy a house, if you want to access that house and you want others not to access that house, you will have a key, right? Those key, if you want somebody to enter your house, you are the only person who should be authorized to allow them, right? But what if all of the person got those keys of your house? They can do whatever they want, right? So that's why this is the same case with the API tokens and the keys, right, which we are using. So they are just like the keys for the house. If somebody got those keys, they can access your system and do whatever they want. So we don't want these keys to leak. So that's why there is a security layer problem which we are having with LLMs, that they don't understand that what to give to the customer or whatever the client or not. Okay, so we need those security layers.
I feel it's really important because since everything was having a numerical value, even if we take example for the checks, it's not randomized. If what if it suddenly matches to a real serial number or something account number, I feel it necessary, I think.
That is really necessary. And the thing is, the data which we are putting on internet, majority of the companies are using those data only to train, right? And there is a security threat which I would like to say is if you think that your communications are really secure, they are not. Okay.
Yeah.
If you are having a Facebook conversation, even if says that your conversations are secure, they are using those conversations, they are using those personal photos which you send, okay, to train their models, right?
Yeah.
There will be a like problematic thing if I want to say, as there was a very serious case from India only that a guy from the college he generated some bad photos of their female colleagues and female students and all, right?
Yeah.
How do you think that they trained those model on, right? They were having some data, right? So,
Of course.
yeah, we whatever we say is we think that companies are good, but they are not that good. Okay, companies are profit oriented. They want their profit. They are not much more like some company. I'm not talking about every company, but majority of companies are profit oriented. They don't think about morals if there is money. Okay, and this is how the corporate and majority of the system works. I should not say it there, but yeah, it's fine. And I just remember you were talking about the hardware things, right? What I remember is there is biosensor hardwares and all. So those hardwares make the computations more faster or the data retrieval and sending better.
Okay.
Few companies are specifically manufacturing these semiconductors and optimizing for the most efficient medical users. They are making those chips most stabilized for the medical purposes. Since I feel uh, there are different categories of application use, so I just heard that also.
Yeah, companies do are working on that, and it is a good thing because these things give us an edge, right? Because instead of using a general purpose processors or hardware, we can use a specialized hardware so that we can get better efficiency, better results, better predictions out of it.
Using the perfect hardware for the perfect application in simple sense.
Yes.
Yeah.
Okay, I feel that's all for today's session. And I
Yes.
didn't have exactly any quiz uh, to ask.
We will start it by next video. I feel that will be fine.
By the way, to all the audience, I would like to know that whether would you like this online sessions or do you want that we should start with the offline sessions which we are doing earlier?
That's
So
really
do
nice
comment it out.
question.
Do comment and
Let us
say that
know.
yeah, let us know that which one works better for you and us.
Yep.
Yeah, that's all for today's guys. Before ending
That's
the
all.
session, I just want to give credits for Drona and Harshita. Thanks for giving the commitment for the podcast. Thank
Thanks
you so
for
much.
inviting.
Thank
And
you. Thank you, everyone.
that's all, guys. We'll see you in the next episode.
See you next episode.